Okay, macromolecule group number 2, lipids. So before we'll just jump into the very first lipid. There's a couple groups of lipids. One is a fat, and we'll do that one first. Then there's cholesterol, and there's our phospholipids. So first we're going to do a fat. And this doesn't fit into our monomer-polymer plan quite so well, but it is a condensation synthesis. So sort of the backbone of a fat is a glycerol molecule. Glycerol is an alcohol because it has all those 3 hydroxyl groups hanging off it. Glycerol is 3 carbons, hydrogens appropriately bonded to the carbon, and then an OH as well. So at each of these OHs, there's going to be a condensation reaction where an H is taken off of the glycerol, an OH is taken off this other unit, and then we put it together with the covalent bond. These other guys right here are called fatty acids. What they're showing you here are 3 fatty acids that look about the same. One thing interesting about fatty acids is that they can come in any number of carbons ranging from, I don't know how many are here, maybe 12 or 13, all the way up to 18 carbons long, maybe 20 carbons long. So carbon, 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 you can count them up and get down to the end. A fat basically is 3 fatty acids attached to 1 glycerol. We're not going to go into the names of the fatty acids, it's not important for us, but just know that they could be sort of different flavors, so to speak, of fatty acids. When you put all 3 of them together onto a glycerol, you have what's called a triglyceride, or, let's see if we can get fancy here. You can have a, nope, it's not working, so sorry about that. Let's can that idea. You can have fat. Next. Fats vary by the type of fatty acid they have attached to them. If all of the carbons on this chain are saturated, meaning they have as many hydrogens as they possibly can have attached to them, it's said to be a saturated fatty acid. They're nice and straight, they pack in really tight, and they'll make a fat that is very liquid at room temperature. Then there are some fatty acids that have double bonds between their carbons. We can draw this out in class tomorrow. The double bond between the carbon takes up one of the carbon's bonds. So now this carbon can only have 1 hydrogen attached to it, 1 carbon, double bond to carbon. Same thing down here. It's said to be unsaturated because it is not full with the most number of hydrogens it possibly can. The result, because double bonds have some constraints around them, they don't rotate quite so freely, they have to have a bend, makes a kink in the fatty acids. So here we have some fatty acids next to each other with unsaturated carbons, and they have these bends in them. These guys are, they prevent close packing. I think I said these are liquid at room temperature. I think that's totally wrong. So ones that pack in together are solid at room temperature. Ones that have the kinks at room temperature, they still kind of get in the way, they move around, these are liquid. Things with unsaturated fatty acids are generally from vegetables, so vegetable oils. Things with saturated are usually from animal fats, so think butter. Think about the difference between butter and olive oil at room temperature. Here's a close-up again. If you've got all your hydrogens attached to your carbons, single bonds all the way down, you have a nice straight molecule. You probably have an animal fat, and you might look like butter. In this case, we've got kinks because you've got the double bonds. Carbon is not saturated, and you have an unsaturated fatty acid, and this would be your oils. Second type of lipid is called a phospholipid. Phospholipids also kind of have that same building block thing going on, and it turns out because of the way they're built here, they make the bilayer for the plasma membrane or the cell membrane. Let's look at it a little bit closer. So here's our glycerol, sort of our baseline guy. It's going to get 2 fatty acids attached to it, and that's the tails. And then it has a phosphate group, With this other head group, it's usually got a charge on it. In this case, it's called choline. Don't worry about the name. It's always got a phosphate attached to something else. These guys, you see the charges, they're going to like water. They're going to interact with water. They can hydrogen bond with water. These guys, hydrophobic tails, carbons and hydrogens are hydrophobic. The electronegativity between a carbon and a hydrogen is almost identical. They don't have a lot of polarity. They like to stay away from water. So think how oil does not like to mix with water. It's because of these saturated carbon tails, hydrocarbon tails that like to stay far away. So again, like that other picture, the head groups, this charged area likes to interact with water. These tails, they are carbon chains with hydrogens. They do not like water. They stay far away from water. We're going to look at this a little bit more again tomorrow. We'll draw some up on the board and have a chance to talk about it. And I notice now I have to bring in a picture of cholesterol. I don't even see it in the PowerPoint from the book, so I'll show you cholesterol tomorrow.